appreciate. It's called a growth, right? It's called a growth. Okay, so here we go. Jeremy mows lawns during the summer to earn money. He's got a job, summer job. At the end of the summer, he wants to put $500 of his money into a bank, into a savings account for the next 3 years. So that means he's going to put money in the bank, not touch it for 3 years. Okay, not put any more money in, not take any money out, just leave it. The savings account at his local bank is giving him 4% interest every year, which is added to the balance of the account. So what I want you to do is tell me how much money is Jeremy going to have after 1 year? How much money is he going to have after 2 years? How much money is he going to have after 3 years? So use your calculator. And how much money is he going to have? So I want you to do that. Use your calculator to fill out the table. How much money is he going to have after 1 year? Does anyone know? Keep working if you're doing. Keep working, but does anyone know the first one? I'm just asking for the first one. The others? $520. Good. He will have $520 at the end of that first year. How do we get 520? What's the process to get 520? What did we do first?
4% interest, I put it to, I made it to 0.04.
Good. Definitely important, right? 4% interest means 0.04. We got to move the decimal or divide it by 100. Good. Keep going. Keep going, Bernard.
And then I multiplied $500 by 0.04 and I got 20.
Good.
So do we get 20 more dollars?
And then you added them together, right?
Yeah.
Perfect. That's perfect. Just like that. Okay? So if you weren't sure, that's the recipe. So do that for the next 2 years. Do that for the next 2 years. So at the beginning of the year 2, he doesn't have $500. He has $520 in his bank account. So if I keep using those same steps, you take 520 times 0.04. You go to your calculator. It's not going to be $20 this time because it's not 500. It's going to be $20.80. $20.80. Then you're going to add that to the total that you already had. Plus, what did I already have? $520, and now I have $540.80. That's how much he has after 2 years. So he's made $40.80 at the end of 2 years for doing nothing. That's the nice thing about interest. Interest could be a good thing or a bad thing. If it's money in the bank, it's a really good thing. You get money for doing nothing. That's pretty nice. If it's a credit card, it's how much you owe to use the credit card. Credit cards are different. They use the same word interest, but credit card interest means how much I got extra I have to pay. Okay? After 3 years. After 3 years, he doesn't have $500. He doesn't have $520. He has more than that. At the start of 3 years, he has $40.80. 0.04. How much interest would he make? $21, and I'm going to round to 63 cents. So then he's going to go his start at the beginning of the month plus and he gets $562.43. Okay. You can keep doing that, but look at what they do on the next one. They jump. They jump from 3 to 10. So could you keep making a table? Could you make a bigger table and keep going? Yeah, but that would take you long. Is there a quicker way we can do this? Well, there is. So let's kind of develop a quicker way. What was the starting? What did I always do to begin with? What did I always do to start when I calculated that? First thing I did. Start with the starting amount, right? The starting amount. Good. How much money did he start with? So it changed, right? But it was a starting amount. Okay, good. And then what did I do? Multiplied by the interest, right? Which was 4%, right? Which was 4%. So I'm going to put this here, and then I'm not going to put 4% because I want to be able to use this for all my problems. So I'm just going to put R instead. R means whatever the interest is, right? So here's where I'm going to take it a little bit further. I add the interest, right? I add the interest. What do I add it to? Whatever he had already, right? He gets to keep that money. Doesn't he get to keep all of that money he already has in there? And then I add in a little more. I add in a little more. I add in a little more, right? What percent of his money does he get to keep every year? What percent of his money does he get to keep? Like the $500. What percent of that money did he get to keep? All of it. What percent is all of it? 100%, right? Except we don't run to write percents as percents, right? So what is 100% changed? What is 100%? One whole. Isn't one whole 100%? So that's where the 1 comes from. And then the years, it's called exponential. Why is it called exponential? I don't have any exponents. Here's your exponent right there. Okay? So I want you to verify that this is true. Go to number 1, year 1. Get your calculators ready. I'll go slow so you can type this in your calculators. Let's verify that this works. Year 1, what was his starting amount? 500. So put 500 there. Parentheses. 1 plus, what was the rate, the percentage? 4%, right? So 0.04. 1 plus 0.04. Close parentheses. What year was the first one? What year was this? To the 1 power. To the 1 power. The exponent button is right under the clear. The exponent button is right under the clear. Hit enter. What do you get? $520, right? $520. Okay. Let's try it for year 2. So that maybe Mr. Flores got lucky. Let's try it for number 2. Now, here's the difference. The starting amount is the beginning amount, not the new starting. So the starting amount is always going to be what they started with at the beginning. So we're not going to put 520 in there this time. What are we going to put? 500. So try this again. 500, parentheses, 1 plus 0.04, close parentheses, to the now 2 power. Put 2 power in there now. What do you get? We get the same thing, right? That, if you want to do it for 3, it would work as well. Okay? So now, how much is he going to have in 10 years? Yep. Y equals starting amount, $500, 1 plus 0.04, and then this guy is going to be 10 now. So we put it into our calculator, 500 parentheses, 1 plus 0.04, close parentheses, to the 10 power. $740.12. How about 15 years? 15 years.
947 cents.
Yeah, it's going to be 900 and something. Let's set it up. The nice thing about these calculators is you can cut and paste. So you can go up to the one that, we can go up to this one in our calculator, hit enter, and then it'll so you can edit it. $900.47, yep. Almost double his money. Now, $500 isn't a lot. So two things, $500 isn't a lot of money. For him it is, but in reality it's not that much money. And 4% interest isn't that high. The more you give your bank, the better interest they'll give you. So if you give your money $500, bank $500, they might give you a low interest. But if you give them more money, $5,000, $50,000, $500,000, they want your money. They want your money. So they'll give you better rates. Okay, that's how it works. That's how the banks work. After T years means any amount of years. So what if I said 30 years, 50 years, 100 years? What would you do? You would use the same exact, but instead of, you would just put T. However many years. Now, does that work for every problem where you're putting money into a bank? No. How much did you start with? What rate did they give you, right? If you started with 1,000, then that would be 1,000. And if they give you a better rate, then that would be there, okay? So it's not going to be used for every problem, just this problem, okay? All right, flip it over. The opposite of earning money is losing money, depreciate. We just talked about it. One of the biggest ways to depreciate money is to buy a car. Everyone needs some way to get from point A to point B, right? So a car is, you need one. You need transportation, right? But a car is not an investment. Putting money in the bank is an investment. It's making you money. Cars are not investments, and I'll show you right now, right? Genesis buys a Honda Civic, brand new Honda Civic. Honda Civics are probably one of the most popular cars out there. For $21,000. That's how much she spent in 2020. That's a lot of money, especially 2020. If I wanted to buy the same car today, it would probably cost you closer to $30,000 just because all prices have gone up. On average, a brand new Honda Civic depreciates in value by about 9.9%. So I started with year zero. The reason I started with year zero is because if I buy a car, it's not 1 year old, right? It's not 1 year old until 1 year. It's like when you're born. When you're born, you're not one. You're 1 month, 2 month, 3 month, 4 month, and then you get to 1 year, okay? How do you think I'm going to calculate depreciation now? Take a wild guess. How do you think I'm going to calculate depreciation? Not division. So appreciation is growth, right? How do we calculate growth? Come here. The opposite of appreciation is depreciation, right? So how do you think I'm going to calculate decay or depreciation? Subtract what? What part? all that's going to change is that's going to be a minus. Everything is going to be the same. Instead of 1 plus r, you're going to get 1 minus r. That's it. That is it. It's the same, almost the same formula. So what I want you to do is use that formula to tell me how many, what is the value going to be at the end of 0 years, 1 year, 2 years, 3 years. Use your calculator to figure that out. What will it be? I'll give you a few minutes to do that. Use your calculator to do that. So the first one, starting amount, $21,000. That's how much it cost her to buy it. Then we go 1 minus, what number am I going to minus? 1 minus what?
0.099.
Divide that by 100. Divide it by 100. You get 0.099. What is the time on this one? What is the time in years on this one? 0. It's not even a year old yet. When you hit enter, what do you get? You get a number that looks familiar. 21,000. Okay. So how much is it worth at the beginning of the year? 21,000. Finish the rest. At the end of 1 year, what is it going to be? At the end of 2 years, at the end of 3 years, at the end of 4 years, what is it going to be? So after, oops, I added, sorry. After 1 year, it was only worth $18,921. After 2 years, it was worth $17,047.82. After 3 years, it was worth $15,360.09 if you round. It's 9 cents. What would her car be worth in 2026, sorry, 2026? Well, what year would 2026 be? 6, yeah, because 2020 is 0, 2021, 2022, 2023. So 2026 would be year 6. C is supposed to be 2030. It was a typo. It's supposed to be 2030. 2030 would be year 10. So how old is her 6-year-old car? Yep, $11,234. Look at what she paid for it, and look at what after year 6. 6 years. That's not a long time. Most of the cars you see out there are at least that old. Most cars are between 5 and 10, older than 5 years on the road. They might not look it, they might be kept up pretty well, but most cars aren't new cars. They're older cars. Almost half. It's worth almost half. So just by her driving it, and that doesn't even take into account if she got in an accident. If she got in an accident or she hasn't been taking care of her car, that number is going to even be lower, right? That's why insurance is so high. Okay? So just by driving her car normally, she lost almost $10,000. It's crazy, right? And then year 10. Year 10, it's worth even less. 10-year-old car is not that old. It's like 7,000 and some, isn't it? $7,404.01. Okay. What formula did we use? Well, for this problem, we said $21,000 is the starting value. We added 0.099, and then we said how many years? Okay. So car or things like that, money isn't the only thing that appreciates or depreciates. What else appreciates or depreciates? Number 3, go to number 3. Population. Population either goes up or goes down. Population. The number of people being born versus the number of people who are dying every day. Right now, or in 2019, at the end of 2019, there were more people being born, more kids being born than people dying every day. That's why the population got bigger. Barely, right? 1%. 1.1% is not a lot, but it's still, right? So if that was at the end of 2019, so 2020, so it's pretty much 2020. What would the population be expected to be of 2040? Is this growth or decay? Growth. So tell me what numbers I'm going to plug in. What's my starting amount? 7.674 billion people. 1 plus, what number am I going to put in here for R? 0.011. 0.011. How many years is it going to be in 2040 versus 2020? So we said 7.674, 1 plus 0.011. If 2020 is year 1, 2021, 2022, 2023, if I keep doing that, what would 2040 be? Close, not 19, 21. It would be 21, yeah. Put that in your calculator, see what you get. It's going to be 9 point something. Oops, I want to. 9.656 billion people. Why is it important to know how many people are going to be on the earth or in our country in 2040? It's an estimate. It's not exact. It's an estimate because it's not 2040 yet. But it's an estimate. Why is it important to know how many people are going to be in the United States or be in the world in 14 years now? Why is that important? How many homes are going to be needed, right? How many homes? When they build homes, they're not already sold. They got to predict how many. So places for people to live. What about jobs, right? Jobs. AI is taking more jobs every day than crazy, right? And we're growing in population and AI is taking those jobs away. Some of the jobs your parents or grandparents did, they're not going to be there when you guys are ready to go out into the workforce, right? So they got to know for jobs. When I retire, I get money. What is that called? Not your retirement, but what is it called? What is our program called? You can learn about it in U.S. history. Social Security, right? Social Security, some of you have jobs already. You already pay into Social Security. Social Security, what they do is they say, here's your money, but what we're going to do is we're going to take out a little bit and we're going to put it in a piggy bank. Not for you now, but for you when you're 65, when you're older and you don't want to work anymore. So you get it when you're 65, okay? Here's the problem though. When they put it in the piggy bank, they don't save it for you. They give it to people. Who are they giving it to? That money that they took out of your check, that money doesn't sit there. It should, but unfortunately it doesn't. Where does it go? To people who are already 65 and 70, you know, your grandparents probably, right? My grandparents passed away, but they were getting Social Security because they paid, right? And if the amount of workers goes down, they're going to have to take more from your check to pay because there's not enough, right? That's why population increase or decrease is important, right? 2040, I'll be retired. You guys won't be retired. You guys will be, you know, add 14 years to your age. You guys won't be that old. You guys will probably be in your early 30s, right? But I'll be retired by then, right? That's how many people are going to be putting money into the bank and money for me. So I'm going to have money, but the thing they're saying right now is we might be going down in population. There might be more kids, less kids, because prices go up. The cost of things go up. And as the cost of things go up, people are like, why do I want to have 3 or 4 or 5 kids, right? Maybe just 1 or 2, because it costs a lot, or maybe not even any kids, right? So those are the things that are going on in our world right now that are going to affect us, not today, but in 2040, you know, those types of things, okay? So what is the equation we used? Y equals 7.674. We said it was growth, and then we did years, right? That's the equation we used, and we just plugged in 21. Okay, so the last problem. The last problem, I'm not going to do that problem. I changed it a little bit. I made it shorter, okay? So that was a regular problem. We'll do that later. But the problem that I want you guys to do is, here are 2 equations. So cross it out and put this example for. They already did the hard part for you. They gave you your equation. They told you what the starting amount is. They told you what R is. They already did the hard part for you. What they want to know is this growth or decay? How do we know if this is growth or decay? What's going to tell us that? The plus or minus, right? Isn't the only difference the plus or minus over here? Okay. So when there's a plus, what are we going to see? Like this guy right here. That's going to be growth, right? That's going to be growth. Growth, right? In between the parentheses, it's bigger than 1. We say bigger than 1. Bigger than 1. Greater than 1. Inside the parentheses. Greater than 1. That number is bigger than 1. Here's another question. What percent growth is this? What percent growth? I know it's growth, but the other thing they're going to ask you is, what percent growth was it? How much did they add? What percent did they add? 8%, yeah. 8%. How do I know? Because we started with 1, right? Don't we start with 1? And then what did they add? 0.08. What is that? 8%. Okay. Last one. Is this guy growth or decay? Is that guy growth or decay? It's decay. Depreciation, I should say. Because if inside the parentheses it's less than 1, less than, that's less than 1. How much less than 1? What percent decay would it be? So it's 8.89 right now. Didn't it start as 1? So how much did they subtract to get to 0.89? How much did they subtract? So like 11%, right? Yeah. They said they started as 1, and how much did they subtract to get to 0.89? That's what I'm asking. Right? What number did they subtract to get to 0.89? 11%. 11%. So it was a 11% decay. 11% decay. All right? That was the last type of question they're going to ask you. Okay? All right, so do 2 things I want you to do. First thing, tape it in your notes. Tape it into page 35. Okay? Let's see. Second thing, come grab your phone. I'll open it up right now since we're done. And tomorrow we'll do practice, okay?